Now we will move to the 2 marks question. First question in 2 marks. Draw the diagram of electric motor and label the following parts. Split ring as well as brushes. 2 parts, very important parts. Split ring or half ring and brush. That is the diagram of electric motor diagram. 2 marks question. Next question. Write the preparation of bleaching powder and its 2 uses. How bleaching powder is prepared and 2 uses of bleaching powder. This is a 2 mark question. Here chemical equation is not asked. Just asked how bleaching powder is prepared. By the action of chlorine on dry slaked lime, we get the bleaching powder. For writing this, 1 mark. 2 uses. 2 uses. For 2 uses, half and half. 2 for each use, half mark. You will get the 2 marks altogether. 2 uses you have to write. Uses of bleaching powder, number 1, number 2. Any 2 uses. Or explain the 2 uses and preparation of POP, plaster of Paris. By heating gypsum at 373 K, it loses its water molecule and becomes POP. Just writing in sentence, not the equation. 2 uses of POP. 2 use you have to write. Any 2 use. Next question. Draw the diagram of reaction showing zinc granules with dilute sulfuric acid. Reaction of zinc granules with dilute sulfuric acid and producing hydrogen gas. 2 marks diagram. Labeled diagram. If the question is given, draw a neat labeled diagram. If they have not mentioned the parts, at least 2 parts you have to mention. 2 parts should be there in your diagram. 2 parts you have to write in the diagram, labeled diagram. Next we will move to the next question. Electrical resistivity of some substances at 20 degrees C is given below. Electrical resistivity is given. Resistivity given in the below table. Copper 1.62 into 10 to the power minus 8. Nichrome 100 into 10 to the power minus 6. Ebonite 10 to the power 15 to 10 to the power 17. Aluminium 2.63 into 10 to the power minus 8. This is in ohm meter. Resistivity SI unit ohm meter. You have to answer these questions based on this table. So what is the first question? Which material is good to use in the domestic wiring? Which one we are using in the domestic wiring out of this? Which is used for the wiring, domestic wiring? And second question is, which material is good to use in the iron box? Which material out of this we are using in the iron box? Justify. Justify is nothing but you have to give the reason. So which material you are selecting and why you are selecting that material. The same table is given in your textbook electricity lesson, that is in the page number 101, 101. That is the table 12.2. This value is given. You need not by heart the values. So based on this, question can be asked. This is given in the textbook. This is the table. From that, some materials selected and given the resistivity, and based on that, questions are asked. So in the same page, see the second paragraph. Second paragraph. In that paragraph, answer is given for your first question. Which material is a good to use in the domestic wiring? So as you know that for the wiring purpose, we are selecting such material whose resistivity should be less. If the resistivity is less, resistance also less. Its resistivity should be less. So if the resistivity is less, its conductivity, it can conduct more current. Its conductivity will be more. So from the given 4 options, which is having less resistivity, least resistivity is 1.62 into 10 to the power minus number 101, second paragraph. Rho is a constant proportionality and is called the electrical resistivity of the material of the conductor. SI unit of resistivity is ohm meter. It is the characteristic property of the material. The metals and alloys have very low resistivity in the range of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. They are good conductors of electricity. So metals as well as alloys. In that, metals have less resistivity. So here metals, copper and aluminium are metals. Nichrome is alloy, ebonite is insulator. So metals have less resistivity. In this least resistivity is copper. So your answer should be which material is good to use in the domestic wire? Answer copper. For writing this half mark. Justification, give reason because it has less resistivity. Its resistivity is less. Therefore, it is a good conductor of electricity. It conducts more. It is a good conductor of electricity. That is the reason, justification. Go to the second question. Which material is good to use in the iron box? So, which material you are using in the iron box? Go to the next paragraph in the same page, third paragraph. In the same page, page number 101, third paragraph, table 12.2 reveals that the resistivity of an alloy is generally higher than that of their metals. Alloys do not oxidize or burn easily at high temperature. For this reason, they are commonly used in electrical heating devices, not only in the iron box, electric iron, toaster, etc. Tungsten is used in the filament of the electric bulb because copper and aluminium, tungsten of electric bulb, whereas copper and aluminium are used for electrical transmission lines. Electrical transmission lines means this only, wiring, domestic wiring, copper and aluminium are used. When comparing copper and aluminium, copper is the best. Comparing copper and aluminium, this is the best because it has least resistivity. So, which one is used in the heating device or the iron box? Iron box is the heating device. In that we are using nichrome. What is the justification you are using? Nichrome is the alloy which has less resistivity, or you can write the main reason for this, nichrome is used because nichrome is an alloy which do not oxidize or which do not burn easily. Alloy do not oxidize readily at high temperature. They do not burn easily. They do not oxidize easily at high temperature. Therefore, nichrome, which material is used in the iron box? Nichrome is used to justify answer or reason because nichrome is an alloy which do not oxidize easily at high temperature. That is the reason. So, while writing these type of questions, the answer should be your textbook answer. You should not write any general answer from your Google or somewhere. The answer should be in the exam paper, answer should be the textbook answer. For all the questions, textbook answer should be there because in the answer key, in the final exam, the answer key will be given, and in that answers are given from the textbook only. Same textbook copy, same textbook answer. So, textbook answer should you have to write. So, other answer if you write, you won't get the marks. Textbook is the final for you. So, this 2 marks question, half plus half, half plus half. So, which material is the good to use in the domestic wire? Copper. Justification because it has least or less resistivity, hence it is a good conductor of electricity. Which material is good to use in the iron box? Answer nichrome because it is an alloy. Alloys do not oxidize readily at high temperature. That is the reason. Now we will move to the 3 marks questions. First question in that, it's a problem. The potential difference between the terminals of an electric heater is 120 volt when it draws a current of 8 ampere. Current is given 8 ampere and potential difference is given 120 volt. That is, potential difference, that is V is equal to 120 volt. Current symbol we are using I, which is equal to current is 8 ampere. Using this current and potential difference, we find out resistance. Ohm's law equation, V is equal to I into R. R is equal to, bring I to this side, V divided by I. So R is equal to 120 divided by 8. 4 2s are 8, 4 30s are, 4 3s are 12, 0, 2 1s are 2 15s are. That is, R is equal to 15 ohm. Along with the SI unit, your answer should be there. Resistance, SI unit ohm, so answer 15 ohm. Now continuation part of this problem. What current will the heater draw? What current? We are going to find out current. What current? I is equal to how much will the heater draw if the potential difference is decreased to 60 volt. Potential difference V is given 60 volt. We are going to find out current I is equal to how much. Already we have calculated resistance, that is R is equal to 15 ohm. So write the formula. V is equal to I into R. I is equal to, bring R to this side, V divided by R. Now substitute the values. I is equal to, the value of V is 60 divided by the value of R. R is equal to 15. 3 5s are 3 20s are 5 1s are 5 4s are. So I is equal to 4 ampere. SI unit of current is ampere. I is equal to 4 ampere. We will move to the next question. Write the 3 factors on which Joule's law of heating depends. 3 factors on which Joule's law of heating depends. So you have to remember this formula. If you remember the formula, easily you can write. What is that Joule's law of heating? H is equal to I square R T. So 3 factors on which Joule's law of heating depends. It directly proportional to square of the current I. Square of the current for a given resistance. Second point, it directly proportional to the resistance for a given current. And the third point, it directly proportional to time for which current flows in the given resistance. It is given in your notebook. The factors affecting Joule's law of heating. 3 factors. For 3 factors, 3 marks. Not the equation asked, but if you know the equation, easily you can write. First factor, square of the current for a given resistance. Second one, resistance for a given current. Third one, the time for which current flows in the given resistance. 3 factors. There are question. Option is given on what factors does the resistance of the conductor depends. Explain. So resistance of a conductor depends on 4 factors. Length, area, temperature as well as nature of the material. First one is length. Explain in the sense how it depends. Explain. As length increases, resistance increases. Second, area of cross section. As area of cross section increases, resistance decreases. Third one, nature of the material. Resistance depending on the nature of the material. And the fourth factor is temperature. As the temperature increases, resistance also increases. So this also given in your notebook. Explain is how it depends. So 4 factors and how these 4 factors depends on the resistance that you have to write. We'll continue with the 3 marks questions. We'll move to the next question. It is a diagram. Draw a schematic diagram of the circuit consisting of a battery, which consisting of 3 cells. Battery of 3 cells of 2 volt each. 3 resistors, resistance 2 ohm, they are connected, parallel in connection. Plug key, ammeter and voltmeter. So, draw a schematic diagram of the circuit consisting of a battery of 3 cells. So, first you draw the battery consisting of 3 cells. This is one cell, second cell, third cell. Connect this. So, one cell, two cell, three cell consisting of 3 cells. 2 volt each. 2 volt, 4 volt, 6 volt. Together it has a 6 volt. Each cell 2 volt, 3 cells 6 volt. It is connected to a plug key. Connect a plug key. Ammeter. It consisting of 3 resistors which are connected in parallel. It is connected to a voltmeter. Voltmeter is always connected in parallel. So, this is positive plus, this is minus. Direction of the current from the positive direction in this way, like this, flows like this. So, here plus, minus, this will be minus, this side will be plus. So, this is plus, this is minus. It is given 3 resistors, they are connected in parallel and the resistance of each resistor is 2 ohm. So, this is 2 ohm, this is 2 ohm, this is 2 ohm, which is R1, this is R2, this is R3. 3 resistors connected parallel, voltmeter connected parallel, ammeter is connected series, direction of the current from the positive direction. So, this is the current flows in this direction. This is ammeter. So, in this way you have to draw the diagram. It is a 3 marks question. We will move to the next question of 3 marks, that is Al2O3 plus HCl gives AlCl3 plus H2O. Al2O3 plus 2NaOH gives 2NaAlO2 plus H2O. With the help of above equations, justify your answer about the nature of the aluminium oxide. What is the nature of the aluminium oxide you have to mention and you have to justify. In this sense, you have to give reason why you are saying aluminium oxide has this nature. Give another example of the compound which is showing the same kind of nature. So first you have to mention what is the nature of the aluminium oxide. For writing that you will get 1 mark, justification 1 mark, one more example 1 mark. So what is the nature of aluminium oxide? Aluminium oxide react with HCl, hydrochloric acid, to give aluminium chloride and water. Aluminium oxide react with NaOH, sodium hydroxide, which is a base, to give NaAlO2, sodium aluminate and water. So aluminium oxide react with the acid, aluminium oxide react with the base. Aluminium oxide react with acid and base to give, this is a salt and this is also a salt, to give salt and water. This type of nature, this type of compound we call as amphoteric oxide. So what is the nature of aluminium oxide? Aluminium oxide is amphoteric oxide. Nature of aluminium oxide. Aluminium oxide shows amphoteric. It is amphoteric oxide. So justification. How you say it is an amphoteric oxide? What you have to write? Aluminium oxide react with hydrochloric acid hydroxide, which is a base. Sodium hydroxide, which is a base, to give salt and water. Therefore, aluminium oxide is amphoteric oxide. Justification or reason: aluminium oxide reacts with the hydrochloric acid to give salt and water. Aluminium oxide also reacts with the sodium hydroxide, which is a base, to give salt and water. Therefore, aluminium oxide is amphoteric oxide. Next, one more question. Give another example of the compound which shows the same nature, which is having same kind of nature. One more example I have given: zinc oxide. Zinc oxide, which also shows amphoteric nature, which is also an amphoteric oxide. Metal oxide, which react with both acid and base to give salt and water. They are called amphoteric oxide. Aluminium oxide is amphoteric oxide because it reacts with the acid, that is hydrochloric acid, to give salt and water. Aluminium oxide also reacts with the base, that is sodium hydroxide, to give salt and water. Therefore, it is amphoteric oxide. That is the justification. One more example is zinc oxide, which also shows amphoteric nature, which is an amphoteric oxide. We'll go to the next question. Question is given like this: a metallic carbonate A reacts with the hydrochloric acid to form sodium compound and liberates B gas. A metallic carbonate, alright? Metal carbonate, that is A, reacts with the hydrochloric acid, that is HCl. To form a sodium compound, we get a sodium compound and liberates B gas. It is a gas. We get a compound B, which is a gas. B reacts with the slaked-line. That B gas which is liberated, that reacts with the slaked-line. Slaked-line means calcium hydroxide. We get one more compound C. Identify A, B, C. Hydrochloric acid react with the metal carbonate. Reaction of acid with metal carbonates and metal hydrogen carbonate we have studied in the chemical properties of acids and bases. So in the chemical properties of acids and bases we have studied acid react with the metal carbonate to give salt and liberation of a gas. Which gas is liberated? When an acid reacts with the metal carbonate, it produces salt with the liberation of carbon dioxide gas. So we will write the chemical equation of this. HCl react with the metal carbonate. Their example we have taken metal carbonate, only sodium carbonate we have taken. So sodium carbonate react with the hydrochloric acid. Sodium carbonate Na2CO3. Sodium carbonate plus hydrochloric acid HCl, we get sodium chloride NaCl, sodium chloride, plus liberation of carbon dioxide gas CO2 plus water. Gas is carbon dioxide. This carbon dioxide gas CO2 reacts with the slaked line. Slaked line means calcium hydroxide. CaOH twice. Slaked line. We get the product is CaCO3 plus H2O. But this CaCO3 is the white precipitate. White precipitate of calcium carbonate is obtained. Reaction continues in the next book. If you pass more carbon dioxide, the white precipitate disappears and we get the calcium hydrogen carbonate. Now we will answer the question. So metal carbonate A is, you have to write the answer. A is Na2CO3, that is sodium carbonate, metal carbonate. And B, identify the gas B. Which is the gas liberated here? The gas liberated is CO2, carbon dioxide gas. B is equal to CO2, carbon dioxide gas. And C, the compound C. Which is the compound C is formed here? Compound C is formed here. This white precipitate of calcium carbonate. No need to write water here because calcium carbonate is given. It is white precipitate. We get a solution of calcium carbonate, CaCO3. So you have to write C is white precipitate of CaCO3. So identify A, B, C. A is sodium carbonate. Just to write down the formula Na2CO3. A is Na2CO3. B is CO2, carbon dioxide gas. And C is white precipitate of CaCO3, calcium carbonate. And also write the chemical equation. So first chemical equation is this. Sodium carbonate react with HCl to give sodium chloride, carbon dioxide and H2O. This is not balanced, Na2CO3. So 2NaCl. Na2, 2Na. This is 2 HCl. Na2CO3 plus 2 HCl gives sodium chloride, carbon dioxide, water. One more equation is carbon dioxide passed through slaked lime, that is calcium hydroxide. We get calcium carbonate, white precipitate of calcium carbonate. You may get one more question along with this. When excess of gas is passed, what is the product we get? When excess of gas is passed, continuation is there in your textbook, reaction. When excess carbon dioxide is gas, the gas is passed, white precipitate disappears and we get calcium bicarbonate, CaHCO3 whole bracket 2. Calcium bicarbonate or calcium hydrogen carbonate is the product we get when excess gas is passed. But it is not asked in this question. Only two equations and mention A, B, C. So this type of question, one question will be there in your question paper related to the chemical equation. They give the clue in the question. Based on that clue, you have to understand which is that, which equation, which the question is asked related to which chemical reaction or which chemical equation you have to decide. One question definitely it will be there in your question paper. So we move to the next 4 marks question. 4 mark questions. The first question is given like this. Write 4 chemical properties of metals. 4 chemical properties of metals. I have given the question, the differences between metals and non-metals on the basis of their physical properties and on the basis of their chemical properties. So in the first column you have taken metal character, second column you have taken non-metal character. So same characters you can mention here. 4 chemical properties in the sense, whatever the points you have written in the metal column, chemical properties, the differences between chemical properties in that first column. So whatever the points you have written for the metals, you have to mention that. Like metals are electropositive, metallic oxides are basic in nature. Usually metals displace hydrogen from dilute acid. So 4 points I have given in your notes. Differences I have given. So when the question is asked, just mention the properties of metals, chemical properties of metals. Then you have to write the first column properties. If it is asked for the non-metals, you have to write second column properties. It may be physical properties or it may be chemical properties. Suppose if the question is asked, mention the properties of metal, then you can combine physical as well as chemical properties. Not only writing physical properties or chemical properties. Just in the question if it is given, mention the properties of metals or properties mercury from its ore with the chemical equation. How mercury can be extracted from the ore? So mercury can be extracted from its ore. This is also given in your notebook and also in the text. Mercury is extracted. The ore of mercury is cinnabar. Cinnabar is HGS, mercury sulfide. The cinnabar, from the cinnabar, mercury is extracted in two steps. Reaction. Cinnabar, when cinnabar is heated in air, when cinnabar is heated in air, it converted into, cinnabar is heated in air, it converted into mercury oxide HgO with the liberation of sulfur dioxide gas. And in the next process, next step, on further heating, if you continuously heat this mercury oxide itself, mercury oxide reduces to mercury with the liberation of oxygen. Oxygen gas is liberated. The extraction of mercury takes place in two steps. Balance the equation. Here O2, here 2 plus 1, 3. If you write here 2, 2 oxygen, 2 2s are 4. So if you write one more 2 here, 2 Hg, 2 sulfur you will get, 2 sulfur. When you write 2 sulfur, 2 2s are 4 oxygen plus 2, 6 oxygen. So you have to write here 3. 2 mercury, 2 Hg, 3 2s are 6 oxygen, 2 oxygen, 2 2s are 4. Together 4 plus 2, 6, 2s, S2, 2s. So it is balanced now. HgO, O2, so here 2 Hg2. How mercury is extracted? You have to write the sentence. Mercury is extracted from its ore cinnabar. When cinnabar is heated in air, we get mercury oxide with the liberation of sulfur dioxide. On further heating, mercury oxide reduces to mercury. So the chemical equation, chemical reaction, first step reaction and second step reaction. In this way, we can extract from its ore, that is, this is cinnabar, HGS. The ore of mercury is cinnabar. Next question. A galvanometer is connected with the coil. Galvanometer is connected with the coil of insulated copper wire. Galvanometer is connected with the coil of insulated copper wire. Galvanometer is connected to a coil. Of insulated copper wire. Copper wires are put there. This is connected. So, do you remember this diagram? Which experiment this? Faraday's experiment. Faraday's experiment on electromagnetic induction. How can you bring a change in the galvanometer reading? By using a bar magnet. If you use a bar magnet, how you can change the galvanometer reading? This galvanometer has a needle. So if the current flows in the coil, needle deflects. If current is not flowing, needle is not deflecting. So how you can bring change in this galvanometer needle? So Faraday conducted experiment based on electromagnetic induction. When this bar magnet is pushed into the coil, the needle of the galvanometer deflected, which shows presence of current. When the bar magnet is pulled out of the coil, once again needle deflected, but in the opposite direction, which shows current is produced in the opposite direction. When magnet is kept stationary, not moving, when this coil is moved, when coil is just pushed inside the magnet, again deflection in the needle. When the coil pulled out of the magnet, deflection in the opposite direction. Next, when both magnet and the coil, if we make them to move, if we move both, if both are moved with the speed, once again there is deflection in the galvanometer needle. But when both are stationary, bar magnet as well as coil, if both are not moved, if both are kept stationary, there is no deflection in the galvanometer, which shows no current is produced. Here question asked, how can you change? How can you bring a change in the galvanometer reading by using bar magnet? When bar magnet is pushed into the coil, needle shows a deflection. Next, when the bar magnet is pulled out from the coil, needle deflects in the opposite direction. So, hence we can change the deflection in the galvanometer. What cause for this? What is the reason for this? So, what is that electromagnetic induction? What it says, due to the relative motion between the magnet and the coil, either you have to move the magnet, or you have to move the coil, or you have to move both. So, what happens? Current gets induced. There is current produces, current flows in this conductor that we call as induced current. So, how this happens? This happens due to the change in the magnetic field. Changing magnetic field. What is the cause? Changing magnetic field. Changing magnetic field produces induced current in the conductor. That is the main reason. When you bring the magnet near to the coil, magnetic field increases. Because this magnet is nearer to the coil. This coil is connected to the wire, which is the conductor. So current flows. Changing magnetic field. In the beginning it was less. When you bring near to this coil, goes on increases. Magnetic field increases. When you bring the magnet near the coil, magnetic field increases. So we are changing the magnetic field from minimum to maximum. Once again, if you pull the magnet outside, it was inside the coil. When you are pulling outside, the magnetic field goes on decreases from the maximum to minimum. Once again changing from maximum to minimum, it changes. So, changing magnetic field produces current in the conductor. We call this current as induced current. Induced current. That is electromagnetic induction. Induced current. So, what is the cause? Changing magnetic field produces induced current in the conductor. So, that is the main reason. Changing magnetic field. That is the main word. Changing magnetic field produces induced current in the conductor. Because of this, we can change movement in this. We can see the movement in this needle. This needle shows a deflection. This needle shows, if it in the beginning, if you pull it, if you take this bar magnet, if you push the bar magnet inside the coil, if the needle deflects in one direction, then when you pull it outside, needle starts deflecting in another direction. So direction of the current is also changing. So how you can bring a change in the galvanometer needle? By using the bar magnet and the coil. When you bring the bar magnet, when you push the bar magnet inside the coil, needle shows deflection. When you pull the bar magnet out of the coil, needle shows deflection in the opposite direction. Third one you can write. When the coil is moved inside the magnet, needle shows deflection. When the coil is pulled out from the magnet, needle shows deflection in the opposite direction. When magnet and coil both are moved, needle shows deflection. You may get question, when you cannot see the deflection in the needle, when the magnet and the coil both are stationary, when both are not moved, then there is no deflection in the galvanometer. What is the reason? Reason behind this, changing magnetic field. Changing magnetic field produces current in the conductor, induced current in the conductor. There should be change in the magnetic field, otherwise there is no current. Changing magnetic field produces induced current in the conductor. The same point is given in your textbook also. In the Faraday's experiment, electromagnetic induction. This is Faraday's experiment. Students, we'll move to the 5-mark questions. 5 marks you will get only one question. So last year it is asked from physics. In the question A, write the differences between electric motor and electric generator. Second question, state right hand thumb rule. According to this rule, what is the position of the thumb to keep the magnetic field in the clockwise direction? And third question, what is the pattern of magnetic field inside the solenoid? So this is 2 marks, second one 2 mark, third one 1 mark. Write the differences between electric motor and electric generator. 2 differences you have to write for 2 marks. So as you know, I have given in the notes generator and motor. Generator converts mechanical energy into electrical energy. Motor converts electrical energy into mechanical energy. This is the first important difference. Second one is in the generator we are using slip rings. 2 full rings are used. They are called slip rings. In the motor, half rings. It is called a split ring. 2 split rings are used. This is the main very important difference between generator and the motor. Generator, 2 slip rings are used. In the motor, 2 split rings are used. State right hand thumb rule. So as you know the statement of right hand thumb rule, imagine that you are holding current carrying conductor in your right hand such that thumb points the direction of current, thumb shows the direction of current, then the finger which is wrapped around the wire shows the direction of magnetic field. This is right hand thumb rule. According to this rule, what is the direction of thumb to keep the magnetic field in the clockwise direction? Clockwise direction, magnetic field remaining 4 fingers. So, to keep them in the clockwise direction, this is clockwise direction. So, keep the magnetic field in the clockwise direction, thumb should be in the downward direction. Thumb should be pointed towards downward. Thumb is in the downward direction to keep the magnetic field in the clockwise. Anti-clockwise, thumb should be in the upward. Here only clockwise is asked, thumb should be in the downward direction. And third question, what is the pattern of magnetic field in a solenoid, inside the solenoid? So there we have studied the solenoid, the pattern of the magnetic field inside the solenoid, the magnetic field is uniform. It is same at all points. The pattern of the magnetic field is uniform inside the solenoid. It is given in the solenoid. When it is given some information about solenoid, it is given the magnetic field is uniform. It is same at all points inside the solenoid. That is the third question. So when you are getting this type of sub-question, question will be asked from the same lesson. It may be from any topic, but the lesson is same. From the same lesson, they will ask the sub-question. For one question, when sub-question will be given, it will be asked from the same topic, from the same lesson. The question will be asked, and also while giving the options also. Option. If the question is asked options, the option will be asked from the same lesson, not from the other lesson. The same lesson you will get the options. So only one 5-mark question.